Okay, today we're going to be doing 8.1, the multiplication of exponents. Let's first start with what 2 squared times 2 to the 7th power really means. It really means 2 times 2, and this one means 2 times 2 times 2 times 2, that's 1, 2, 3, 4, times 2 times 2, 1, 2, 3, 4, 5, 6, and 7. That's what these two mean. So if I have 2 squared times 2 to the 7th, all you really have to do is get these two exponents and add them together, which will give me 2 to the 7th, 8, 9 to the 9th. And let me prove that right here by showing you that there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you ever forget the rule that when you're multiplying exponents, you add the exponents, all you have to do is break up those exponents into their root forms, which is 2 times 2, and in this case it's 2 times 2 times 2 times 2 times 2 times 2 times 2, and add all those 2's together. And that'll give you the first rule of multiplication of exponents, where if you're multiplying exponents that have the same base, and in this case the base is the same because it's 2 and 2, and the exponents, you add the exponents and keep the base the same. Let's do the next one, which is a little bit harder because now you are raising a 4 to the 3rd. Let's do this. This means 4 times 4 times 4. And you're asking the person or the mathematician to raise this 4 times 4 to the 2nd, which means I'm going 4 times 4 times 4 times 4 times 4 times 4, which becomes a total of 1, 2, 3, 4, 5, 6 fours here, which now I can make this become 4 to the 6th. Now remember that what I've done here is I've taken 1, 2, 3, 4, 5, 6 fours, and I've made that up here. And since 4 is the base, I've left the base alone here also. The other way of doing this, you can say 3 times 2 is equal to 6. So my exponents are now equal to 6. What that does is I could say all this is equal to 4 raised to the 6th power. And once again, that was derived from 3 times 2 is equal to 6. So long as the base, and here's my base right here, is the same. Pretty easy. So these are two rules. When you're adding exponents, when you're multiplying numbers with the same base that have different exponents, you add the exponents. And in this case, when you have parentheses, you multiply the exponent of everything that's inside the exponent. Let's go to one that's a little bit more complicated. Okay, here's an interesting one. Now, the 3 is not part of this. It's just this is a third example here. So I'm saying everything inside of this parentheses is raised to the 3rd power. So I'm going to have to do 3 raised to the 3rd times a raised to the 3rd. And on this one over here, make sure this one here on this side is, my color's correct, 2. And it becomes 2 raised to the 2nd power and a raised to the 2nd power. What that does is now I have all these numbers, and these are all multiplied by each other. I've broken this down so it's easier to see, remember. So my question to you is, can I combine this number that is raised to the 3rd and this number raised to the 2nd? You're answer should be no. I can't just multiply the exponents because the base, notice the base, 3 and 2 is different. So the only thing I could really do is break this up into its components, which is, in this case, 3 times 3 times 3 times, this gets broken up into 2 times 2. Okay? So this becomes 3 times 3 becomes 9 times 3 becomes 9 times 3 is 27. 2 times 2 is 4. 27 times 4 is... So here we have the 4, which becomes 4 times, 27 times 4, which will give us 108. Now let's deal with the exponents. Now remember that this, or notice that this base is the same as this base, and when you're multiplying exponents with a similar base, you add the exponents. So 3 plus 2 in this case gives me 5. This becomes a to the 5th power. So my answer in this case, my final answer becomes 108 a to the 5th power. And there's my answer for how to do those with parentheses. Okay, let me make this more complicated for just a second. Dealing with the negative. If I have negative 3 raised to the 2nd power, what this means is 3 times 3, which is equal to 9, and it's a negative 9, because the power is only related to the 3, not to the negative. So if this was negative 3 raised to the 2nd power, then your answer would be negative 3 times negative 3, because the negative is related to that power, and negative 3 times negative 3 gives you a positive 9. That's how you deal with the negative in the situation. This is a tricky little situation, and it always trips up even my best students when we deal with the negative in that respect. Let me give you an example here. Negative 2x to the 3rd raised to the 5th power. So what this means is negative 2 to the 5th x. Now remember, we're multiplying now, x to the 15th. And you could either leave it, if you wanted to simplify it, you could simplify it from there. So the other answer is 2 raised to the 5th power is 32, I think. 2 times 2, 2 raised to the 5th power is 32. This becomes a negative 32x to the 15th, which is the most simplest form of this equation right here. Well, I hope this helps you guys, and we'll go on to 8.2 in a second. Thank you very much.